Good morning. Today is September 12th. I am doing a long video today, and special occasion. This box is one of the original Qboxes that Smokeless Chimney made, and it was in service for a whole year or a whole heating season. It came back to us because it was a loaner box, and the customer wants it back. They are agreed to pay the money for the box. So, that was a significant event. It hasn't even had the vinyl pulled off the label. So I'm going to go over the box, how it works, things I had to do to the box. You can see that this is serial number 15. It's running some code we developed. I'll go over the first number at the top here. Try to find first number at the top here is stove temperature. It's hooked up, and I bet you if I find the end of it here, I can heat it up and it'll change temperature. So there, see, change temperature. Now this is not necessarily important that it be accurate at room temperature. Thermocouples, I can put an offset in here in the software if I need it to be accurate at room temperature. However, I've got two more temperature gauges on the PC board, and they're saying it's 76 degrees, 74 degrees, and I'm looking over at mine, and it's about 76 degrees in here. The reason we use a thermocouple is it's accurate in the 500 degree range where I need it, and you can see when I grab the thermocouple, the sensor end, that the temperature does come up. Here, I'll grab something off my workbench and make it really hot. Oh boy, that's not going to be easy. Alright, so we have 450, 500 degrees. And thermocouples are very good in the high range. Okay, so this has been plugged in. I have three 18650 batteries up here. I don't ship them with these. These are my test batteries. These produce a 12 volt signal that runs through some circuitry on this board and drives this fan. This fan is a 13.5 cubic foot per minute fan. I have it running and you can see the pressure coming out. It's running at a bare minimum right now. The control buttons are all up here. Alright, let's go down the list here. So this is a pressure sensor that's on the board that's measuring the atmospheric pressure. I think this is humidity. I have a PM1, PM2.5, and PM10. This has a PMS 5003 on board, and it is giving me smoke numbers, smoke values. This board is running a version of the code we developed, and the Stokio code, and it works pretty well, but it uses a SAM D20 chip that is difficult for me to communicate with. I've got a few of these boards running. They are costly to make one of these units. So I'm working on a lower cost version of this. This one is an example of feature creep. So I had a lot of features I wanted to put in, and it's running the version 0.08 version of the code. So I'll run it through some of its, let's see if I hit a button here, if I hit the right button. So now the fan has spun up to 50%, and we can see we're going up over 0.6 inches of water column here. I'll bring it down. Let's see here. So 4 is the lowest number. It uses a function to spin the fan up, and then it starts the pulsing. So when a wood stove is in idle mode, I like to run it in the 4 mode, because the fan will spin slowly and then spin up, and then you can see that it keeps a little bit of air moving out the wood stove at all times. Now, one thing I can do is I can pull off this power supply. So now this unit has no power. It'll run for, I'll say, 4 hours operating the fan. The problem is the screen. The screen seems to pull a fair amount of power. And I don't know that it pulls more than the fan, but units I've had that just run the fan and have no screen tend to run significantly longer. I like the screen. It's just a difficult thing to program around. Alright, so I'll turn this thing around. This is the back of the board, back of the unit. And the problem I was having with these units is that they power cycle. And the software that's on the board accommodates being power cycled. So I don't know how to get it to do it here, but it looks like this. I'll turn the switch off. When it power cycles, it comes up like that, and you get that blue, and you get the screen filling in, and then you get it starts to run fine. The fan will spin up, but then it goes into normal operation, or remembers where it was. It just isn't a great thing that it power cycles. It does work fine when it's power cycling. I have some that power cycle every 10 seconds, and I'm just not going to send those out to customers. What I did on this one was I put a power supply or a power filter inside the box, and I might take the back of the box off. This is going out to the customer today, so I'm showing how I've set the box up and how I've this box has been running for a year at the customer site. He's very happy with it. He thinks he's burning less wood, and he's not seeing any smoke out of the chimney when he's using it. He has a Quadra-fire wood stove, and he wants this box back. Alright, so I'll pull the back off so you can see the other side of this. Alright, so I have this little power module in here, and it takes the power from the batteries, which is 12 volts, and it refines it before it goes onto the board. And I've reduced the number of power cycles because I've brought the power down to 11.4 volts, so it doesn't. The reason I think I'm getting power cycles is that once the batteries are charged up, this thing provides about 12.4 volts, and the board doesn't like 12.4 volts. It likes 12 volts or 11.9 volts. And so once the batteries are all charged up, the voltage floats up, and it's too high for the board. It starts power cycling. And this unit right here is rather large, but it keeps it from power cycling. Back in there, there's also a PMS 5003. You can see the blue shiny light. I hope you can see that. I'll turn it just a little bit. All right. That's the view of the back of the board, of the back of the device. There's about 5 of these out in the wilderness. I've got a better design, or at least an easier to make design. The SAM chip, the SAM board that we commissioned to have make, is not an inexpensive board, and I don't know, it just it's very difficult to communicate with. The amount of equipment I have to have, and the programming environment is not, it's not friendly. I was just having a difficult time with it. The Arduino IDE programming environment, or development environment, has a lot more how do you say, there's more assistance, or more people willing to help you out, or there's more code out there that you can borrow from, and it's easier to talk to the boards. The amount, I'll have a video on how I ended up talking to this board, but just not something I want to continue. Okay. Now, a couple things this firmware does do well is it has a PID controller in the software, so when you're in startup mode, it'll look at the stove temperature and try to keep it, adjust the fan so the it'll try to adjust the fan so that it keeps the wood stove heating up and try to get it into the Goldilocks zone. And a lot of work was put into that, and it works really quite well. It helps during startup, it helps during, and it prevents it from going above 425F. So it does a lot of things right, and it was a good prototype. It works. The customer wants it back, and so what I'm going to do is I'm going to take these batteries out and put it in a box and send it to the customer. It's ready to go. It's as good as it's going to get. It's his from this point out. And I thank you for watching.